So in this video we're going to talk about capacity design. Capacity design is a design method in which you design a structure for a certain failure mechanism. It has the procedure for capacity design. It involves 6 steps. First, you must select the desired failure mode, or mode of failure. So this can be flexure, this could be shear, this could be whatever mode you want your beam to fail in. Typically you're going to select a ductile failure mode, such as flexure, and then design your beam to withstand the other failure modes. Alright, so the second step is we want to provide sufficient strength. Sufficient strength for that mode. Next, you want to detail the mode for ductile behavior. So this would be typically, in flexure, this would be making sure that we're tension controlled, that we have our failure in our steel, which is ductile. The fourth step is then for us to determine a probable strength. So this means that we're going to look at the overstrength, or actual strength of the structure. Typically, steel rebar is over what you designed for, so we want to account for that in step 4. Step 5 is then we determine the forces required to reach the probable strength. And then finally, in the 6th step, we'll design the rest of the beam. So we'll design the other elements of the structure to withstand these forces. So this can be seen in several different cases. One of them is the case of the laboratory test. In the specimen you see up in the right-hand corner, this beam was designed to fail in a shear mechanism. So first what we would do is we determine that we want it to fail in shear. We would then detail the shear stirrups to resist whatever load we wanted to. Then we'd come back and say, what is the actual strength of these shear stirrups? And then design the flexure reinforcement so that we could resist, ensure that it wouldn't fail in flexure, but it would instead fail in shear. So that's capacity design.